Yesterday I given differences between overloading and overriding. Okay. Covariant return type. I think all people not understood. That is, I'll explain once again. Covariant return type. See what I given covariant return type. See, Java permits subclass type as a return type while overriding a method. This is only called covariant return type. This is known as covariant return type. See, actually one rule is there in overriding. In method overriding, in method overriding, return type must be same. Return type must be same except covariant return type. That is a given. Okay. In method overriding, return type must be same except covariant return type. This is a given. Say here A class extends B class. A class, here B class extends A class. You observe here return type integer, method name get. Okay. Here return type float, method name get. Now, first of all, is it overloading or overriding? Overriding. Method name same, parameter list same. It is called overriding. Method overriding. Okay. But here what is their rule? In method overriding, return type must be same except covariant return type. It is there. Now, if you write like this, it is not valid. It is not valid because return type here integer is there, here float is there. Not same. But it is not covariant also. Covariant concept is not applicable from primitive data types. That is only reference data types. Okay. So return type must be same except covariant return type. Now here return type not same. It is not same. And it is not covariant also. That's what it is error. It's an error in Java. Either you write here float. Otherwise here integer or here also integer. Then only valid. But one is integer, one is float. It's an error. So different data type if you write, it's an error. Different data type if you write, it's an error. Okay. Now, what I did yesterday, I given like this. Class test. Okay. Class demo. Extends test. Class sample. Extends demo. That is again, no? Now, here super class is test class. Super class is test class. Next is demo class. Test inherited in demo. Demo inherited in sample. Okay. So test inherited in demo. Demo inherited in sample. Now what I'll do here in the place of integers, in the place of integer, in the place of float, I'll write return type is class type. Class type also we can write. See, here I'll write return type something test. I'll write. Here also return type test I'll write. Is it valid or not valid? Valid. Here also test. Here also test. It is valid. But if I write demo also valid. If I write demo also valid. But it is not same. But how it is valid? This is only covariant. This is only covariant. This subclass if you write, it is called covariant. That is valid. But how it is valid? If you create demo object, in the demo object, test members are present or not present. That's what valid. That's what valid. Suppose if I write sample, is it valid or not valid? Valid. In sample class object also test present. That is the reason valid. So suppose here if I write test, here if I write test, here what are the classes valid? Test also valid, demo also valid, sample also valid. Okay, right. Suppose here if I write demo, here what are the classes valid? Demo valid, sample also valid. Subclass, sample is subclass of demo, no? Valid. Suppose if it is sample, what is valid? Only sample valid. Is it clear now? Understood all? So this is the concept of covariant return type. Whatever you are writing here, that class valid, that subclass valid. Okay. Suppose here I written sample, here I'll write test. Is it valid? Not valid. Because here test object if you create, in the test object sample not there. That's what not valid. Whatever is here, that class valid, that subclass valid. That subclass is called covariant return type. That subclass is called covariant return type. Actually, this feature JDK 1.5 came. Starting it was not there. It's an error only. Starting. Okay. Now, this is the concept. If primitive types, if you write, same type required. Primitive covariant is not applicable. Primitive type variables, covariant is not applicable. Suppose here integer is there. What is required here? Here integer only required. Suppose here boolean is there. In a subclass, boolean only required. Here boolean only required. Okay. Covariant return type applicable for reference type only. Okay. That is covariant return type. Next. This is over. Next, I given first method overloading, method overriding definition. Same name, different parameters, overloading. Same name, same parameters, overriding. Okay, like that you can identify. Overloading return type, any return type valid. Same return type also valid, different return type also valid. But overriding only restrictions many are there. Same or a covariant. Now that is overloading, same class also possible. Overriding, not possible. Compulsory inheritance required. Overloading, inheritance also possible. Overriding, compulsory inheritance only, no other option. Next, these four you have seen. What is the fifth difference? Fifth difference. Access modifiers can be same or different. Same also valid, can be same, can be different. Overriding side. Overriding side. Same or less restrictive. Must not be more restrictive. Now, first of all, How many access modifiers are there? 4. What are those? Private, protected, public, no name. Which is default? No name. In these 4, which is a more restrictive access modifier? Which one? Private. Private. Okay. I'll write here only in the program better. I'll write here. Private is more restrictive. After private, no name. Nothing but default. So default also okay, valid. Next, protected. Next, protected. Last, public. Last, public. It is more restrictive to less restrictive. More restrictive to less restrictive. Okay. Now here, suppose void show integer a, void show float a. This is overloading or overriding? It is overloading or overriding? Overloading. Method name same. Parameter list is different. It is overloading. In overloading, access modifiers can be same, can be different. Suppose it is, I'll write private. It is, I'll write protected. Is it valid or not valid? Valid. Suppose it is public. Valid. Suppose it is no name. Same also write, different also write, any style you write, valid. Overloading restrictions are not there. Overriding only many restrictions. Okay. Now, if I write like this, is it overloading or overriding? Overriding. In the same class, can we override? Can we override? No, it's an error. Suppose class sample extends demo. Here void show int a. Is it overloading or overriding? Overriding. Is it valid or invalid? Valid only, no? No, valid. Access modifier rule, same or less? Okay. Suppose here I'll write protected. Okay. Here I'll write public. Now here protected. Here either same you ought write or less restrictive you ought write. Now is it same or less or more? It is not same. Less or more? Less. Valid or not valid? Valid. So this is I written. Less means right side. More is left side. Okay. It is more restrictive. It is less restrictive. So I written this one. I written this one means right side is less. Left side is more. More to less I given. Either right, reverse also, whatever it may be. Concept important. But like that only don't think. Right side only less side. You may write reverse also. Okay, that will be happen. Concept important. If protected is there, here public valid or not valid? Valid. Suppose here public is there, here protected is there. Valid or not valid? Valid or not valid? Not valid. Not valid. Okay. See, here public is there, here protected is there. Not valid. In superclass, public is there. In subclass, what is valid? Only public. Because public only last. Next is not there. Okay. Here public is there means here what we can write? Only public. Only public. We cannot write other. Okay. See. Suppose here no access modifier. No access modifier. That means default. Is it valid or not valid? Valid or not? Valid. Suppose public. Valid or not? Valid. Okay. So year protected. Year what are valid? Protected also valid. Public also valid. Suppose year public. Only public valid. Suppose here no access modifier, no name. Here what are valid? No name valid, protected valid, public valid. Clear? Now, once again, here public is there. In subclass what are valid? Public only valid. Here protected is there. Protected valid, public valid. Here default is there. Default valid, protected valid, public valid. Here private is there. Wait. Last one more point is there. Private methods cannot be overridden. Okay? If private is there, all are valid is wrong. Private, that is also one point is there. Last point. You see? Last point. It is there, no? Private methods cannot be overridden. Because private members cannot be inherited. Because private scope is within the class. Okay? Private is there, all are valid is wrong. Private we cannot override first of all. It is not possible. Because suppose if it is private. Now, you already studied. Here, if you write like this, overriding concept is, you studied. A class show method overridden in B class. Like that I said, no? No. But this method, will it come to sample class? No, because that scope is there only. It will not come. If you write like this, it is not overriding. It is not overriding. If you write like this, it's an error. Overriding not possible. Here, what will happen if you write private? This method belongs to this one. This method belongs to this one. Like that it will understand. It is not called overriding. It is not called overriding. But it is valid only. This method belongs to this class. This method not came here. It's another method. Okay? Here, that means two show methods are there. That show method belongs to that class. This show method belongs to this class. That type. Okay? So if private is there, this is we cannot access here. It's another show method. That type it will understand. That's what it is not called overriding. It is not called overriding. What do you mean? Say, suppose here public is there. Here what are valid? Public valid. Now public only valid. If you write like this, error. Suppose I written public. This meaning this method overridden here. Okay? This method overridden here. Clear? Suppose it is protected. It is protected. Here public valid or not valid? Valid. This method overridden here. Okay? Now, if I remove protected, if I don't write any access modifier, valid or not valid? Valid. This method only overridden here. Suppose here if I write private, is it valid? Actually here, this method not overridden. It's another method. That method not accessible. That's what it is not called overriding. It is valid only, not called overriding. Error will not come. Error will not come. If I compile this code, it is successfully compiled. This method belongs to this class. This method belongs to this class. Same names are there, but not overriding. Same. I give an example. From relatives family, one person came to Hyderabad, is staying in your home. That is nothing but overriding. But here In that family, one person name, your family, one person name, same is there. That person not came here, this person not gone there. But those people, both the people are names are same. That type. Name same, but not overriding. In their family, one person name, your family, person name, same names are there. But it is not overriding like. That person belongs to that family, this person belongs to this family. But names are same. That type. Understood? So, this method, is it accessible in sample class? Is it accessible? No, it's another method. But method name show only. Like that it will understand. Like that it will understand. This will be considered as another method. But if you remove private, this method only overridden here. It is not another method, that method only. That method came here. From A class to B class, demo class to sample class came. Like that it will understand. That is overriding. Okay. This is the concept of access modifiers. Is it clear? I'll ask some questions. Give me answer once again. Here protected is there. Here protected is there. Here public is there. Valid or not valid? Valid. Write this one. It is valid. So method overriding, more restrictions are there. Overloading, no restriction. Overriding only many restrictions. Is it over? So it is protected method. So protected is this one. Less restrictive. This is. So here it is more restrictive. Here less restrictive. More restrictive. Here less restrictive. More restrictive, less restrictive. Okay. Is it clear? Now, suppose it is public. It is protected. Is it valid? Not valid. Okay. Write this one. Is it over? So method overriding, it is not valid because it is more restrictive. I given just now examples. Now, suppose it is private. Now, it is public. It is valid, but not overriding. Valid, but not overriding. It is not called overriding. This concept is valid. This show method belongs to demo class. This show method belongs to sample class. That's what not overriding. Say one show method, two definition. That is called overriding. Two show methods means it is not overriding. See, one minute. Now, what is this? 5. What is this? It is called overriding. 5 is there, 6 is there. Is it overriding? Like that. 5 is there, 6 is there. But side by side. It is called overriding. It is not called overriding, no? Like that. Here, same there, but not overriding. Okay? It is not overriding. It is valid. Syntactically, it is right. There is no mistake. But it is this concept is not called overriding. Okay? Valid, but not overriding. In the above example, private show method belongs to demo class. And public show method belongs to sample class. In the above example, private show method belongs to demo class and public show method belongs to sample class. Method name same is there, but it is not called overriding. Understood? Valid, but not overriding. Syntactically right. There is no mistake. But it is not called overriding. Say like this core Java, every point if you know, advanced Java, JDBC, advanced Java, Solid, like Java EE, Spring Boot, microservices, Hibernate, Selenium, this is all nothing. With this knowledge, remaining all becomes very easy. If you are perfect in core Java. Because remaining all depends on core Java knowledge only. Core Java most important. Okay. Is it over? Core Java only most important. Core Java only most important. Okay. Like core Java most important. Just now explained, no, more restriction not valid, less restriction valid. That means actually where we use this concept is suppose class student. This project is developed by one person. Student 2 extend student. This project modified by one more person. class student 3 extends student 2. According to trend, you are changing project. It is first version project. It is second version project. It is third version project. This project developed by one person. This another person just added new features, some modified existed features or removed some features. But he didn't develop complete project, no? Like this project also, like that only. This person, third version also. But actually this person developed. First project, one person developed. Whatever he given restriction, more than that, he cannot give second person. More than that, third person, he cannot give. In a hierarchical order. So project manager, team leader, team member. Who will restrict more? Team leader or team member or project leader? Project manager can restrict. But team member, nothing. Team member, he has to do whatever given by team leader. But team leader should listen project manager, project architect. So many hierarchies will be there, no? Like that. So in organization, levels, level 1, level 1, level 2, level 3, level 4 staff will be there, no? Level 1 having higher authorities, so many. But level 2, definitely less. Level 3, again definitely less. Level 4, definitely less. Like that. Same possible, less possible, more not possible. That is the concept. Based on real world examples only, these concepts introduced. Okay. This is a concept. Next, final methods can be overload. Final methods can be overload. No, yeah, we can overloading. Final methods can be overloaded. Overloading, no restriction. Final methods can be overloaded. Overriding, not possible. Not possible, no. Final purpose is preventing overriding. Final purpose is preventing overriding. But again, if you override, error comes. If you don't want to allow to override, then only final we use. Okay. That's what final we cannot override. Static method can be overload. Yes. Overriding? No. Because static, if you write, what will happen? Object is not required for static. Now see, suppose it is static. It is static. If you write this method demo.show, this method sample.show, it is not overriding. It is not overriding. Demo.show, sample.show. It's another method, not overriding. Like that. That's what static methods cannot be overridden. Final methods cannot be overridden. Private methods cannot be overridden. These all points, remember, don't forget. Next concept, still polymorphism related. Upcasting. Note down. Upcasting. Assigning an object or object reference, assigning an object or object reference of subclass to superclass type. Assigning an object or object reference of subclass to superclass type is known as upcasting. Upcasting done by system implicitly. Upcasting always valid. Assigning an object or object reference of subclass to superclass type is known as upcasting. Upcasting done by system implicitly. Upcasting always valid. See these 3 points. If I write diagram like this, which is superclass, which is subclass? A is a superclass. A is a superclass. B is a subclass. A is a superclass. B is a subclass. Okay. Now, assigning an object or object reference of subclass to superclass type is known as upcasting. That means B class object or B class reference, if you assign to A class, that is called upcasting. Up. It is up. That's what upcasting. That's it. Okay. So subclass object or subclass reference assigned to super. It is up only, no, like that upcasting. The word like that only. Okay. So B class object or B class reference, if you assign to A class, that is called upcasting. Now suppose for examples, see examples. Here A OB equal to new B. In this line, which class object created? B class. Which class reference created? B class object assigned to A class. Okay. That means B is subclass or superclass. Subclass object assigned to superclass. This is called upcasting. This is called upcasting. So valid upcasting. It is valid, always valid. Second one. B OB1 equal to new B. A OB2 equal to OB1. Now, in first line, which object created? Which reference created? First line, this second one, first line. In second one, first line, which object created? Which reference created? Is there any typecasting? No. No typecasting, nothing. Same class object, same class reference. Now OB1 is a reference of which class? B class. Assigned to which class? It is upcasting. It is upcasting. Valid upcasting. Upcasting done by system implicitly, automatically done. Upcasting always valid. No restrictions. So B class object or B class reference, if you assign to A class, that is called upcasting. B class object or B class reference, if you assign to A class, that is called upcasting. But first example, second example, what's the difference? In first example, second example, what's the difference? In first example, object assigned. Second example, object reference assigned. Got it? First example, second example, difference is here directly object assigned. Here object reference assigned. Okay? That is only assigning an object or object reference of subclass to superclass type is known as upcasting. Upcasting done by system automatically. Upcasting always valid. How it is valid? In both the cases, which class object created? B class. In the B class, A members are present or not present? That's what valid. That's what valid. Okay? That's what both are valid. Clear? It is simple, but downcasting complicated. Upcasting very easy. Downcasting very difficult. Now see. Is it over? All people written? No. Next one, downcasting. You can give answer just reverse. What is downcasting? Assigning an object or object reference of superclass to subclass type is known as downcasting. Right, this one? Assigning an object or object reference of superclass to subclass type is known as downcasting. Assigning an object or object reference of superclass to subclass type is known as downcasting. Just reverse. Assigning an object or object reference of superclass to subclass type is known as downcasting. Now don't write these examples. I'll get time for writing. According to first two examples I give, give me answer what we have tried here. Suppose A is superclass, B is subclass. Then what we have tried? B OB equal to new A. It is first one. Second one. A OB1 equal to new A. Next, B OB2 equal to OB1. Okay. Now, if you write like this, it is called downcasting. It is downcasting. It is downcasting. Okay. But here, one more point is there. Don't write. No, don't write. Don't write. I'll give time. Downcasting must be done by programmer explicitly. Otherwise, compile time error occurs. Downcasting must be done by programmer explicitly. Otherwise, compile time error occurs. So, explicitly we have to do. Now, how to do explicitly? See, B OB equal to, in the brackets, B new A. If you write like this, starting type conversions you studied, no? 56 conversion, like that. In the brackets we are writing, no? That type. It is called explicit type conversion. Fourth one. And here A OB1 equal to new A. After this, B OB2 equal to, in the brackets, B OB1. If you do like this also, not valid. Why? I'll explain. Here, this is nothing but forcibly myself I am converting. Now, A class object, forcibly I am trying to convert, but not converted. Here also, A class reference, forcibly I am trying to convert, not converted. Because, you observe, here in all the cases, which class object created? Which class object created? A class. In A class object, B class members are there? No. Forcibly if you convert also not possible. Forcibly if you convert also, it is not possible. Okay. Say, forcibly if you try to convert also, it is not possible. For example, in class, all are listening properly? No. Few people forcibly also sitting, no? Forcibly with parents force, or like a faculty force like that, they may sit. But will they listen? No use. Forcibly. You should have an interest to learn. Then only possible. If you don't have an interest, forcibly if you sit also, wasted. Time waste, money waste. No use. Okay. Here also, forcibly if you try to convert, not possible. Here, A object, A object, A object, A object. There is no B memory. Forcibly, if you try to convert, also not possible. Okay. Now, actually, you observe downcasting. If you want to do, compulsory upcasting required. That is one more point. Downcasting always needs upcasting. It is compulsory. See, for example, these are steps. Okay, these are steps. Now, the person is here. The person is here. When this person will come down, whenever this person goes up, this person only will come down. Okay. Suppose whenever this person goes up, then only will come down. Up is there, then only down. Otherwise, no up, no down. Okay. So down purpose, first up required, then only down possible. Okay. Suppose this is first floor. Like who will be there here? Whoever came up, that person only will go down. No one will be here, no? Whoever came up here, that person only will go down. That means down purpose, first up required. Without up, down is not there. Here also, downcasting always needs upcasting. So, what I'll do, see here, fifth one. Now, fifth one, AOB1 equal to new B. Here upcasting or downcasting or no casting? What is? It is upcasting. Okay. Now, B OB2 equal to OB1. It is upcasting or downcasting or no casting? Downcasting. It is A reference assigned to B, no? But still it is not valid. Because this concept followed, but this concept not followed. Explicit conversion required. That's what. That is also not valid. 6. AOB1 equal to new B. BOB2 equal to BOB1. It is valid. Here you observe A is a superclass, B is a subclass. A is a superclass, B is a subclass. So your doubt is where we use these all. Okay. If you wait just 1 week, if you wait, every day we'll use. Every day I'll show you. Okay. Where we use upcasting, where we use downcasting, every day we'll use up and down. See, it is superclass. It is subclass. Without upcasting, without downcasting, there is no project, there is no application. Every day we use. Now, like this, it is called down, reverse. Downcasting. Okay. Now you observe A class object or A class reference. If you assign to B class, that is called downcasting. See, it is A class object, A class reference, up and down diagram only. In a coding, all are straight lines only. Okay, up and down diagram, up and down appears. But yeah, upcasting also, downcasting also, straight lines only will be there. Now, A class object or A class reference, if you assign to B class, that is called downcasting. Here, which class object created? Assigned to which class? It is downcasting only, no? It is downcasting. Here A class reference assigned to B. It is downcasting only. It is A class object assigned to B. It is downcasting only. It is downcasting only. Here it is downcasting. This is downcasting. These are downcasting only. But valid or not valid required. Downcasting must be done by programmer explicitly. Compulsory explicit conversion required. One more, downcasting needs upcasting. Now, first, this one, in this line, is there any upcasting? No. Is there any explicit type conversion? No. That's what it is, invalid downcasting. Invalid downcasting. In this line, is there any upcasting? No. Is there any explicit type conversion? No. So it is also invalid downcasting. Now, in this line, is there any upcasting? No. But explicit type conversion is there. But only one rule followed, one rule not followed. It is also invalid downcasting. It is also invalid downcasting. Here explicit conversion is there, but upcasting not there. In fifth to first line, what is this? It is valid upcasting, but it is invalid downcasting because explicit conversion not there. It is valid upcasting. It is valid downcasting. So invalid downcasting. Invalid downcasting. Okay. It is invalid downcasting. Now I'll ask some questions. Give me answer before writing. Don't write now. First write. Give answer. Invalid downcasting. Invalid downcasting. Here it is valid upcasting. Okay. It is invalid downcasting. It is valid upcasting, valid downcasting. Valid upcasting, valid downcasting. It is valid downcasting. Now, give me answer. Why fifth one is not valid? Why fifth one is not valid? There is no explicit type conversion. Okay. Why third and fourth not valid? There is no upcasting. Why first and second not valid? There is no upcasting. There is no explicit type conversion. So first of all, while doing downcasting, we need to check whether upcasting is there or not. If it is there, again we have to check whether explicit is there or not. If it is there, then only valid. Otherwise not valid. Okay. But first of all, why upcasting required? For getting memory. See here, which class object created? B class. In a B class, B members also present, A members also present. That is the reason you can assign any style. But in first to four, only A object. First to four, only A object. A object means only A memory present, no? That's what not possible. That is the reason upcasting required for downcasting. Memory purpose. If upcasting is there, memory comes. This is here actually which class object created in first line sixth one? B class. Memory present for A also, B also. But assigned to A. That's what up. That's what up. But OB1 nothing but A class. Assigned to B. Downcasting. With explicit type conversion only possible. If you write forcibly, it will bring the memory. Otherwise, it won't bring the memory. That is the reason explicit required in this situation. Okay. Now, in 6 examples, one only valid. 6th one valid. Is it clear? Understood? Write this one. I'll explain with one more example. Whether you understood or not, I'll check it out. Okay. Yeah, I'll explain. So further, these upcasting, downcasting every day required. So once again, I'll explain. I'll check it out whether you understood or not. Otherwise, what will happen? You will feel you understood. I'll feel all understood. Okay, that will be happen. If I don't ask any question, you will feel you understood. I'll feel all understood. That's the reason every day I'm asking questions. If I ask question, you will get it your status. I'll get it total classroom status. Is it over? See, subclass assigning an object or object reference of superclass to subclass type. So superclass object or superclass reference not completed. First you try to first complete. Because it's the most important topic. Most important topic. Every day required. Every application requires this concept. See, superclass object or superclass reference, if you assign to subclass, that is called downcasting. So that means A class object or A class reference, if you assign to B class, that is called downcasting. Here, A class object assigned to B, it is downcasting. Here A class reference assigned to B, downcasting. Here A object assigned to B, here A reference assigned to B, here A reference assigned to B, here A reference assigned to B. These all downcasting only. Okay. But here first line upcasting, here first line upcasting. Now, downcasting must be done by programmer explicitly. So like this is called explicit type conversion. If I write like this concept is called explicit type conversion. Explicit type conversion. That is myself I'm converting. Explicit type conversion. Okay. So explicit type conversion, myself I'm converting. Okay. Downcasting always needs upcasting. Suppose according to that, this is in first line. In first line, upcasting is there because B object assigned to A. B object assigned to A. This is assigned to this one. So it is upcasting. Here explicit also is there. Here OB1 assigned to OB2. OB1 is A reference assigned to B. It is down. So it is upcasting, it is downcasting. As well as explicit type conversion also is there. So according to these all rules, it is valid. But why fifth one not valid? There is no explicit type conversion. Why third and fourth not valid? There is no upcasting. Why first and second not valid? There is no upcasting. There is no explicit type conversion. Clear? Now, whether you understood or not, I'll check it out. Okay, with some examples. For example, now my questions carefully listen while giving answer. Okay, carefully listen first. This is which type of inheritance? Which type? Hierarchical inheritance. The hierarchical inheritance, no? No. A class, B class, C class, D class, here, E class, F class, G class, H class. Now, my question carefully listen. E class object I'll assign to A class. Is it valid or not valid? Valid or not valid? What is this? Upcasting. E class object I'll assign to A class. Subclass object assigned to superclass. It is upcasting. Upcasting always valid. Okay, it's clear. Because E object if you create, A members also present. A members also present. That's what always valid. Now, one more. E class object, I'll assign to A class. Again, A class object reference, I'll assign to E class, F class with explicit type conversion. Once again listen. E class object, I'll assign to A class. This A class reference, I'll assign to F class with explicit type conversion. Is it valid or not valid? Valid or not valid? How many people answer valid? So majority valid. Okay. Next, how many ones are not valid? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See, now what you are thinking is up is there, explicit is there. That's not valid. You are not seeing memory also. If we create E object, in that E object, what are the classes memory present? E class. Next. If we create E object, what are the classes memory present? E memory, B memory, A memory. F memory is there. But how can you assign? All are valid, you are saying. What you are saying, up is there, explicit is there. Up is there, down is there, explicit is there. Suppose in this building you came up. From that building, can you go down? From this building only you have to go down, no? Like that. In this building you came up. From that building or this building, can you go down? From this building only you have to go down. Okay? So, like this up. Again reverse here only possible. Other route not possible. Because if E object if we create, E object if we create memory allocated to E class, B class, A class. But where is F memory? F memory not there. How can you assign? Understood? So don't see only up is there, down is there, explicit is there. See the memory also. Actually, up what purpose? Memory purpose only up. Now one more question. One more question. E class object assigned to A class. Okay, listen with concentration. E class object assigned to A class. A class reference assigned to B class. Is it valid? Listen with more concentration, I said. E class object assigned to A class. A class reference assigned to B class. I didn't say explicit. Is it valid? Not valid. Because no explicit. Okay? Now, E class object I'll assign to A class. A class reference I'll assign to B class with explicit type conversion. Valid. Okay? While doing up and down, suppose. While doing up and down, suppose H class I assign to A. Reverse, you can assign to that subclass. Other classes not possible. Same route it should come back. Same route. Other routes not valid. Got it? This is up and down, upcasting, downcasting. Clear? We'll see continuation next class. Next class on Monday. Tomorrow is a holiday. So next class on Monday. Next class on Monday, 7:30. Okay. Happy Ugadi to all. Happy Ugadi to all. Thank you. Wish you the same. So next class on Monday, 7:30. Next class on Monday, 7:30. Tomorrow is a holiday. Next class we'll see on Monday.